Good morning. Okay, I thought I had grabbed my 092 lab manual, but I had grabbed my 151 lab manual last time I was on campus. So is there any way that somebody can just take a picture of the nomenclature lab, the two like main pages, and email it to me really quickly so that I can see what those are? That would be super, super helpful. If there's anyone who can do it. And if you don't have your lab manual, you want to have your lab manual. So take a minute to grab your lab manual because we will be looking at that a little bit today. I think it's lab 7. It's nomenclature. Okay. So we had finished off talking about naming ionics with polyatomic ions. Let me share my screen. Yeah, so we had left off here. We had been combining metals with some sort of polyatomic ion. We did metals that were type 1 or predictable charges. We also did metals that were type 2 with unpredictable charges. We're just having to add the Roman numeral. And anytime there's a polyatomic ion, we don't need to change that. So we don't ide it, we don't truncate it or anything like that. We're just going to keep it as its regular name. We talked about our axions. Okay. So now what happens when we have two nonmetals? So let's say we have something like carbon and oxygen. Well, the thing with two nonmetals is that because they're not transferring electrons, they can combine in a variety of different ways. They're molecular compounds. Here we can see the word molecular. And that means that they share electrons and they have a couple different combinations. So you can have things like carbon with 1 oxygen, that would be carbon monoxide. You can have carbon with 2 oxygens, that would be carbon dioxide. So it's not enough to just say you have carbon and oxygen, you have to actually specify how many of each you have. So we will go with the name of the first element. This is going to feel a lot easier than the last ones, but we're going to do the name of the first element. And that's going to be the thing that's more metal-like, or the thing that's closer to the zigzag line. And we're going to add a prefix in front of it. And the prefix is going to tell us how many of them there are. And I'll show you the prefix list in just a minute. Then we're going to name the second thing. We're going to do just like we did with the metal, non-metal, where we do the base name of the second element and we ide it. And we also want to add a prefix. And the prefix, again, is going to tell us how many of each of the thing that it's next to we have. So we don't flip-flop charges. We don't have to do anything like that. All we're gonna do is put a prefix for the first guy, name the first guy, put a prefix for the second guy, name the second guy, but item. So here are the prefixes. 1 is mono, 2 is di, like diatomic, 3 is tri, like tricycle, 4 is tetra, like tetrahedral, 5 is penta, like pentagram, 6 hexa, 7 hepta, 8 octa, nona, and deca for 10. So you do need to know up through 10, or have them somewhere where you can reference them. And then it's really just as simple as smushing that in front of the elements that you have. So there is one exception as far as using prefixes. This is the only exception. So when looking at this thing, the first thing is carbon, and I have one of them. So it would be monocarbon. I have 2 oxygens, so monocarbon dioxide. But I'm allowed to drop the mono prefix only if it's on the first guy, okay? So I don't call this monocarbon dioxide. I call it carbon dioxide. That's the one exception as far as dropping. Let's go over here. Just a second. So when we have something like CO, mono, carbon, monoxide. Now I'm allowed to drop the mono if it happens on the first. So we don't call that monocarbon monoxide, we call it carbon monoxide. Only the mono gets dropped on the first though. Let's say we had something like this, C2O3. This would be dicarbon trioxide. Thank you, Leanna. I appreciate that. Awesome. Thank you so much. Okay, so now I have them. Sorry. All right, so dicarbon trioxide. Going back to the slides, the compound N2O, which is also known as laughing gas or nitrous oxide, we would call this dinitrogen monoxide. Since like a couple, I'm not going to really test you on the spelling. I'm not going to have one where the vowel is dropped and one where the vowel isn't dropped as your options. But since mono ends with a vowel and oxide begins with a vowel, the O is dropped so that we get monoxide. We don't get monoxide or 2 O's next to each other. There are some cases where the vowel is dropped, and there are some cases where the vowel isn't dropped. So in monoxide, it's dropped, but in dioxide, we keep the I and the O. Or also triiodide, you keep both of those I's next to each other. Again, I'm not going to be like a stickler, and you won't be tested on that, but you do need to know like which prefix to use when. So hopefully that feels really easy compared to the other ones. The tricky thing is what will happen. People start using this set of rules with metals and nonmetals, and we don't want to do that. We want to keep these things separate. And so I'm going to give you a couple of these, and I want you to work through them. So work on those 4. Okay, so this first one here, so you're, whatever the ordering is, name them in that order. So sulfur, we would say first, and I have 3 of them. So tri sulfur, and then I have 5 oxygens, so that'd be pentaoxide, or probably pentoxide. This next one here, we've got phosphorus, and we've got 4 of them. So tetraphosphorus. 1 chlorine, so monochloride. And again, don't forget to ide the second, guys. This one here, 3 nitrogens and 6 oxygens. We don't reduce like we do with metals and nonmetals. So this would be trinitrogen hexoxide. oxide. This is probably, I think it's hexaoxide. I'm not really 100% with the vowel dropping either. This guy here, we've got diiodine, heptafluoride. And that's it for metals and nonmetals. Like, that took us like 16 minutes to go over. So much easier than, or I'm sorry, for two nonmetals, for molecular. So molecular or nonmetals is much easier than metal nonmetals. Metal nonmetals, took us 2 lectures. Let me give you a couple going the other direction, and I want you to write the formula. And we'll move on to acids. So, silicon trifluoride, octanitrogen, non-chloride, tribromine, hexanitride. And one more. Nitrogen monoxide. All right, so for this first one here, silicon trifluoride. So we've got 1 silicon and we've got 3 fluorines. Here I've got nitrogen and I've got 8 of them. I've got chlorine and I've got, definitely don't have 11. We have 9 of them. Tribromine, so bromine with a 3, nitrogen with a 6. Again, we don't reduce these. So if this was a metal, non-metal, we'd reduce it to 1 and 2. We're not going to do that here. Nitrogen monoxide is just going to be NO. Any questions on these here? If I was to write this, I would not call this dialuminum trisulfide. Why? What is this first thing here? This is a metal. If we have a metal, I want you to keep prefixes away from it. Prefixes don't happen. Instead, we balance charges. This would be aluminum oxide. Okay, so this uses a different system. Let's go back here. So the last thing that I want to talk about are naming acids. So when we have an acid, the first thing we need to do, the first step is to identify that it is in fact an acid. Acids are molecular compounds that will dissolve in water. They're composed of hydrogen that usually is written first to the formula. For the sake of your class, if you see an H first, you can assume it's an acid. And then we're going to have one or more nonmetals written after that. We can categorize our acids into being either binary or oxyacids. A binary acid is an acid that contains just one other thing. So like HCl. HCl is an example of a binary acid. HBr is an example of a binary acid. An oxyacid is an acid that is a hydrogen combined usually with a polyatomic ion that has oxygen. So H2SO4, that would be an oxyacid. HNO3, oxyacid. All right, you guys seeing the difference between these and these? Binaries are the simpler guys. Oxyacids have the polyatomics. So how we're going to name this is be different than how we name this. So decide if it's an acid. If it is an acid, it'll have the H in the front. If it's binary, or if it's an oxyacid. If it happens to be binary, this is how we name it. You say the word hydro, and you take the base name of the nonmetal. So the hydro is sitting in place for the hydrogen. You take the base name of the nonmetal and you ick it, and then you say acid. So let's go back to HCl. That's hydro, chlor, ic, acid, hydrochloric acid. HBr, hydro, hydrobromic acid. Okay. It's a little bit more complicated if, let's go to the next page here. You can see some of them. So hydrochloric acid, hydrobromic acid. There is one exception to the truncation rule. If you have H2S, we don't call it hydrosulfic acid, we call it hydrosulfuric acid. So they use the full name of sulfur in that. All right, if you have an oxyacid as your polyatomic ion, you're going to name it differently. So HNO3 contains nitrate. H2SO3 contains sulfite. H2SO4 contains sulfate. It's important to know whether it's an ate ion or an ite ion. If it's an ite ion, the name, you don't put hydro in the front, so polyatomics won't have hydro. You're going to say the base name of the oxyanion, and you're going to us it, and then write the word acid. So if I have this thing here, HNO3, I don't say hydro because it's got a polyatomic ion. I look at this polyatomic ion. This polyatomic ion is nitrate. So if it And then, sorry, I didn't get to the second one here. Let's do HNO2 first. This thing is nitrite. Okay, so ITEs become us. So this would be nitrous acid. ATEs become ick. One way to, so ITEs become us, ATEs become ick. One way to remember is I ate something icky. Okay. So this thing here is nitrate. So we would call this nitric acid. All right, the original ATE gets dropped and becomes ick. Ate, icky. Ite, us. We don't hydro either of those. The next page has a bunch of examples. So there's our nitrous acid, our nitric acid. This is sulfite, so this would become sulfuric acid. This is sulfate, this would become sulfuric acid, so on and so on. So that's all of nomenclature. We're not done. Now we want to do some practicing, but that is the whole gist of nomenclature. So the first thing is to determine, right, is it ionic, is it molecular, or is it an acid? The way that we name each of these is different. If it's ionic, is it a metal with one type of ion, or is it a metal with two types of ions? If it's a one type, drop down, we have this. If it's two, you can use this. Non-metals or molecular, we use our prefixes. And then acids, determine if it's binary or oxy acid, and go from there. What I don't want is to see this stuff happening over here or this stuff happening, over here. So it may actually serve you to print something like this out and have it available for you when you're doing your next exam, which is a little while away. Okay, so we are going to spend some time today working on our lab for the class, and I'm going to do a couple with you guys, and then I'm going to put you into some breakout rooms with probably 4 of you each to a room. So you will be able to work together with some other people going through some of these things. So the lab is going to be set up a little bit different than the lecture, and that the lab is everything jumbled together and mixed together. Juliana was nice enough to send me the lab, so I'm going to do that now. There is this first page here. So when looking at the lab, the first page where it talks about valence electrons and Lewis dot structures, I just want you to cross this out. I don't want you to do this right now, okay? This is just more work than it's worth explanation-wise. We will come back to this information in a couple chapters, but I don't want to do it right now. So with this first page, we have a series of metals on the downside and non-metals or polyatomic ions across. And so in the matrix, you're going to combine these things to write the correct formula. And then it's the same thing repeated down here, but I want you to write the name. Okay? So for this first one, we have K plus combining with Br minus. So K plus and Br minus. Metals and nonmetals for both of these, you will be honoring flip-flopping. So it would be KBr. So you could fill this first one in with KBr. This next one here is just asking for the name of what that was. So that is potassium and bromine, which becomes bromide. All right, so potassium bromide is going to be filled in that. Let's do this box over here together. And this down here. Ooh, come on. So In this one, we're combining Cu plus with oxygen O2 minus. So the formula for this will flip-flop will be Cu2O. Cu2O. And then to name this thing, we're going to name it as, I'm going to write it over here, copper. But copper has an unpredictable charge, so I need to put its charge in there. What's the charge on this copper? It told me that it's 1. So copper 1 oxide. So in this bottom thing, all the copper should have a charge of 1. Yeah, that's how the first page goes. The next page, what we've got here, this is a big, fun, long list of formulas, and you need to give me, zoom in here a little bit. You need to give me the names. So how I want you, like in your group, to go about these, I mean, it's up to you, but you know, you can work on a couple together by yourself and then come back together. You can work on each one together. But everybody needs to be looking at these and determining, okay, is this an ionic compound? Is it a molecular compound, or is it an acid? When I'm looking at this, I see that that first thing is a metal, so I know that this is ionic. Is this metal predictable charge? It actually is. Remember that silver gets a +1 charge always, so I don't need a Roman numeral. And then I also have a polyatomic ion happening in this. So if I'm going to name this, I'm going to say the metal first, which is silver. I don't need to put a Roman numeral because we know silver is always a 1. And then I need to say the name of the polyatomic ion, NO3, which is nitrate. Silver, nitrate. The next one here is, I have to decide, is this ionic, is it molecular, or is it an acid? This is molecular because those are both nonmetals. So I need to be using prefixes for this. First guy here is iodine, and I have 1. I can drop the mono, so this is going to be iodine. How many chlorines do I have? 3, so iodine trichloride. And we're done, okay? And you're just going to keep working down the list. Let's go to the final page. All right, the final page is going in the opposite direction in that it gives you the name and it wants you to write a formula. So for this first one, I need to determine, is it molecular, is it ionic, what's going on? This is ionic. So I need to be doing charge balancing. Barium always has a 2+ charge. Chlorine always has a -1 charge. Flip flop, BaCl with a 2. The 2 is coming from the charge over here. This here is ionic, and it is an unpredictable charge, but that's why they give you this, because that tells me the charge. So lead is Pb with a 4+ charge. Perchlorate is a polyatomic ion. Just reference a polyatomic ion sheet. ClO4 with a -1 charge. So what I need to do is flip flop. I should have 4 of these for every 1 of these. Pb parentheses ClO4 parentheses 4 of those guys. Let me clear this out. If I'm looking at number 8, Okay, number 8, carbon tetrabromide. That is molecular. It's two nonmetals. So I'm going to say the name of the first nonmetal, carbon. How many do I have? Just one. Tetrabromide, so that's going to be bromine, and I have 4 of them, and I'm done. All right. So with that being said, I'm going to put you guys into breakout rooms. It's 8:39. I am going to give you until about 9:05. I'll send you guys a message when you can come back out. Try a couple on each page, okay? Don't just get through the first page. Do a couple on the first page and see, okay, we're starting to get this. Do a couple on the second page and on the third page. How to quickly determine an oxyanion. Yeah. So do you mean as far as like what their name is going to be, or just being able to identify them? Because if I'm looking on this list here, I can tell which ones are oxyanions because they're going to end in ATE or ITE. So oxyanion, oxyanion, oxyanion. That's all you need. Okay, cool, great. Stop share. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 of you. Okay, I'm just going to break us up into 3 rooms. And then I'll be around. So if you have a question, you can just throw it in the chat and I can come over, or I'll just sort of like sneak in, talk with you guys. All right. You are ready to go. Hey.
I just have a question. On the first page in the chart, the first row and the third column, the KNO3, because the 3, it has, do you put the NO3 in parentheses even though you wouldn't notate the charge?
So which one specifically? You said you're combining the nitrate with potassium?
Yeah, and they both have a 1 charge.
So you don't need to put it in parentheses. The only time you put it in parentheses is if you have more than one of them.
Well, the nitrate is NO3, so wouldn't the 3?
The 3, here, let me share my screen with you guys.
Okay.
And then it's easier for me to show you what I'm talking about. Okay, so we're combining this K and this NO3, right?
Mm-hmm.
So, oh, well, I just wrote it for you. Okay, K plus NO3 minus. So I want you to sort of think of this as a grouping or a packet with the charge on the outside. So whatever your charge is here, it has to talk about the entire thing. So this is a 1 magnitude, this is a 1 magnitude. So you're gonna have one of these for every one of these. So KNO3. The reason I don't put that in parentheses is because I just have one of them. And if you're like, well, how will someone know that that's NO3, that's like a packet together? They will know.
Okay.
Okay, what if we did the next one, which is calcium, Ca2+ with the NO3. I'm gonna circle this out. This 2 is gonna tell me I have 2 of these. This 1 is gonna tell me I have 1 calcium, so it's gonna be, hello, Ca, come on, Ca. I'm gonna put it in parentheses, NO3, because I have to have 2 of those.
Okay, I
So
get it.
the parentheses is only if you have a multiple of them.
Okay.
Good with that?
Yeah.
All right, cool.
Thank you.
Yeah.
See.
Hey, so if you guys have any questions while you're working on them, you can just send me a message, okay?
Okay. Wait, I have a question real quick.
Yeah, if you have one right now, you can ask me.
For the one, the third one across, the K, would I leave the 1 alone? It'd just be K parentheses NO3, like the 3 on the outside.
I was just talking to another group about that. So let me share my screen with you.
Okay.
All right, so when looking at this, just throw this out so we can do it fresh. If I have potassium, potassium is gonna be K and it's a plus charge. Nitrate is NO3 with a minus charge, so we flip-flop. So I have 1 potassium and I have 1 nitrate. I don't have to put the nitrate in parentheses because I only have 1 of them.
Oh, okay.
But let's look at the next one, the calcium. So if I take calcium, which is 2+, and combine that with the nitrate, and I flip-flop, I have 1 calcium, right? But the nitrate, I'm gonna have to have 2 of these. So I will put it in parentheses, NO3, and I'm gonna multiply it by 2.
Okay.
All right, does that work there?
Yes, thank you so much.
All right, well, you guys message me if you have any other questions, okay?
Yes, ma'am.
I got a question.
Okay, just sneaking in for a sec to let you guys, if you have a question, you can write me like a comment and it'll say, hey, people in room 1 have a question.
Oh, okay.
But since I'm here, you can ask me. What's up?
Okay, for the second box, are we supposed to switch the numbers like how it says P3 minus and then the potassium K1 plus? Are we supposed to switch those numbers or no?
Yes. Okay. Let me
Okay,
share my
okay.
screen with you. So all of those combinations in the boxes are combining metals and nonmetals. So when we combine metals with nonmetals, we need to balance charges. So you said it was potassium, K plus.
Mm-hmm.
And what was the other thing?
The other one was P3 minus.
Okay, phosphorus, yeah, P3 minus. So this has a magnitude of 1. So that is going to become the subscript of this. This is going to become the subscript of this. So it should be K3 P1.
Okay.
1 goes down here, 3 goes down here. Okay. And any other questions with that?
As of right now, I don't think so.
Not for right now.
That makes sense.
Okay, yeah, and the reason you do that is the fastest way to get it charge neutral. So if we look, let's look at calcium. Ugh. Calcium with a 2 plus, and then the nitrate, the polyatomic ion, the NO3 minus. I think it's somewhere in there. Find that on the matrix. Okay. So treat this as a packet that has an overall -1 charge. You can treat this as a packet because it's an element, and it has a 2 plus charge. So we're going to flip flop. So I have 1 calcium because the 1 gets dropped down to here. So calcium is a 1. Nitrate, I have to have 2 of them. So I'm going to put it in parentheses, and then I'm going to put a 2 around the outside. The 2 gets dropped down here. The 1 gets dropped down there. Flip flop. Questions?
Okay. That makes sense.
Okay.
Just so the
I don't believe
sorry,
you.
I'm playing catch up because I was taking pictures earlier, so I'm still trying to like figure out
Okay.
what's going on.
Oh.
So the charges don't matter at all. It's just like the amount that you're basically
It's
flipping.
the exactly. It's the magnitude.
Okay.
Because like if this whole molecule, when it's a metal and a non-metal, the whole molecule, it has to have a 0 charge. So if phosphorus has a 3 minus charge and I have 1 of them, that's an overall 3 minus charge, right?
Mm-hmm.
If potassium has a 1 plus charge and I have 3 of them, because we've done the flip-flopping, that means I have a 3 plus charge here. 3 plus and 3 minus equals 0. It's the fastest way to figure out your charge neutrality. You want whatever your positive thing is to equal whatever your negative thing is. So that's when you had K plus, let's say we have K plus and Cl minus. Well, that's just going to be a 1-to-1 ratio because this is a +1 and this is a -1. One of those and one of those will equal a 0 charge. That's what we're trying to head towards. Does that make sense?
Yeah, that does.
Why we're flip-flopping? Okay. So like, for instance, this guy here, this has a 2 plus charge. So this has got a strong positive charge. This thing only has a 1 minus charge. It's a little bit weaker. So I need 2 of these to balance out 1 of these because this is twice as strong as in its charge. That's
Okay, that makes sense.
Okay, that's why we're flip-flopping. It's like, yeah, I sort of believe you, but that's the point, is to get it to be equal to 0, the charge.
No, that totally makes sense. I need to know the why, or I don't get it.
Yeah. There are other ways of doing that conceptually. You could just say, oh, well, obviously, if this is a 2 plus and that's a -1, I need 2 of those in order to, but that's just the fastest way to do it.
Okay.
Okay.
That's good.
Cool. I'll leave you guys for a couple more minutes. Let me know if you have any questions. Okay.
Okay.
Cool. Bye.
Thank you.
Mm-hmm.